This is Mr. Barron. I'm going to be showing you how to do the Lewis dot structures for the problems in the covalent bond formation worksheet. So I'm on part 3, and I'm going to be showing you how to draw the structures. For H2, and all of these structures here, what we want to focus on is forming octets unless it's hydrogen. Hydrogen only needs 2 valence electrons to have a noble gas electron configuration, so we say that it forms a duet. It only needs to have 2 valence electrons in any of its orbitals to be happy. All the other elements follow the octet rule. Now, we will eventually learn that there are some elements that don't follow the octet rule. For now, this worksheet in particular, everything follows the octet rule. I will tell you when you are not following the octet rule, and that's not this worksheet. So beginning with this one, we have hydrogen. We know that it only needs a duet, which is just 2 valence electrons. So what I do is I write H2 and I count, actually I should do it over here. But yeah, I have 1 valence electron for each hydrogen atom. So it's a total of...
Excuse interruption. Carla Figueroa, please come to the main office. Carla Figueroa to the main office.
So there's 2 valence electrons. And what I'm going to do is I'm going to start by figuring out who the center atom is. But because there's 2 atoms, and that's it, there's no center atom, so I just begin by connecting my hydrogen atoms. That's one single covalent bond, which represents 2 valence electrons. So I've used all of my valence electrons, have none left. I have a duet for both hydrogen atoms. This one has 2 electrons around it because it's next to the stick, which represents 2. Same with the one on the right, so we're good to go. That's the structure. Let's move to the next one. So nitrogen has 5 valence electrons. Each hydrogen has 3, so that's a total of 3 valence electrons, so I have a total of 8 that I can use in this molecule. So I begin by writing out nitrogen. Nitrogen has 5 valence electrons, which means it has 3 unpaired valence electrons. The element that has the most unpaired valence electrons is typically in the center. Nitrogen will be in the center. So I'm going to draw nitrogen, then connect it with 3 hydrogens. Each of these sticks represents 2 valence electrons. So I'm going to count those up. 2, 4, 6. Subtract those 6 valence electrons from the 8 I had available. I have 2 valence electrons left. So I begin by spreading them on the outside, but I can't spread them on any of the hydrogens because each hydrogen has access to 2 valence electrons. It's formed their duet. So instead I'm going to go straight to the middle. Add them as a pair. There we go. I've used my last 2 valence electrons. I have 0 left. Check that I have all octets and duets taken care of. Each hydrogen has 2 valence electrons next to it. The nitrogen has 2, 4, 6, 8 next to it. So nitrogen has its octet, and that's our structure. Could have drawn this with the H's in different positions, and this is called a lone pair, this thing right here. The lone pair could have been in a different position as well, but that works. All right, I'm going to start moving a little bit faster. So carbon has 4 valence electrons. Each chlorine has 7 valence electrons. And don't forget that you use the periodic table to figure out the valence electrons. Don't forget in particular that these group numbers tell you how many valence electrons they have. So chlorine has 7, there's 4 of them, so there's 28 valence electrons. So I have a total of 32 in this atom. So the correct answer for this one, I start with carbon, have the 4 chlorines around it, spread around the valence electrons, so I've used 2, 4, 6, 8, subtract the 8, I've got a total of, 24 left. So I'll spread over 24 around, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There we go. I've got my molecule. So I've used all 24. I have 0 left. Everything's got an octet. I'm happy. All right. This one is a tricky one. I'm going to save the tricky ones for the very end. I'm going to write out the answers for the easier ones first, okay? CS2 requires a double bond. I know that because of the following steps. Carbon has 4 valence electrons. Each sulfur has 6, so that's a total of 12. So I have 16 valence electrons to work with. Carbon has the most unpaired, so it's in the middle. Spread out my sulfurs. When I connect the sulfurs, I've used 2, 4 electrons. Subtract that from my total, and I have 12 valence electrons left. So I spread the 12 evenly. I like to spread them symmetrically on the left side and the right side. So I begin 2, 4, 6, 8, 10, 12. I've used all 12. I have 0 valence electrons left. Now, since I spread them on the outside, I check to see if I have octets. Got an octet on that sulfur. Got an octet on that one. This carbon doesn't have an octet, and that's when I know there's a double bond. So I move these in to form a double bond, and I have 2 double bonds on the carbon, and then each sulfur is connected like that. There's the answer. Okay, let's move to the next one. PI3, not even going to show the work on this one, I'm just going to draw it out. Should look like this. You might get to the point where you're as fast as me, but preferably I'd like you guys to follow the same steps that I showed in the earlier problems. NF3, almost identical to the way I just drew out PI3. Very, very similar. There we go. And again, if you have questions, please ask them in class or during a tutoring session. Move on to the next one. This one's a little tricky. I'm going to come back to it at the end. Okay, SiCl2H2, same thing. I know silicon's got the most unpaired valence electrons, so it's the center. I do my count, do the count like I've taught you in the previous problems. Oops. It's typical to mess up when you go too fast. See, I put 3 chlorines. I only have 2 chlorines and 2 hydrogens. So the structure should look like this. I've got 2 hydrogens, 2 chlorines. You could have put them on different positions around the silicon. And then the octet for the chlorine. There we go. Done. Okay, OF2. Alright, making sure I've got all my octets. And again, I would have done the total in the beginning, you know, counting 6 valence electrons for the oxygen, 7 for each fluorine, so that's 14, so I had 20. And then I connected these, subtracted 4 because each stick was 2, had 16, and spread them out that way. So, with this particular problem, I've got my octets and I'm good to go now. I've used all of my electrons. It's always good to do an extra count. So I've got 6 plus 14, which is 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Good to go. All right, next one. So this one's confusing, but I'm going to address it right now. And it's the fact that you don't know who the center is. Well, in chemistry, oftentimes what we do is we write formulas in a way that tells us how things are connected together. So I see this, I wonder, when I look at this, I first look, I'm like, why the heck are these two not together? Why isn't this formula CH4O? Why is it CH3OH? Well, the reason it's written like that is because these two are connected together, and these are all connected together. So it's like you almost have 2 centers. So I have the carbon with all the hydrogens around it, and I've got the oxygen with the hydrogen connected to it. So I know I've got a couple parts going on. I know I've got a carbon with 3 hydrogens sticking to it, and then I've got this oxygen, and well, it's got to be connected to the carbon because it can't connect to any of the hydrogens here. And then the oxygen's connected to the hydrogen here. So then what I would do is I'd count out the total, and I'd go like, okay, so there's 4 for that, 3 for the hydrogen, 6 for the oxygen, 1 for that last hydrogen. You end up with 14, valence electrons available. Count how many I used: 2, 4, 6, 8, 10. I used 10, so I have 4 valence electrons left. I only have one place I can put them. That makes an octet. Right there, done. That's the molecule. That's called methanol, actually. So that's the way I would approach those types of problems, where the order that it's written sometimes tells you who's the center when it's not who's clear what the center atom is. Like this is clear who the center is. This is clear who the center atom is. This one's not as well. Let's go over this one really quick. So again, there's a reason why those O's were split up. It's probably because this is connected to that. So you've got these connected together, and then you've got the N and the O connected together. So I'm going to stick them together, H to the O, the N to the O, and what the heck, I'll connect the O and the N together because it looks like that's the order they're connected. Count my electrons, I've got 1 for the hydrogen, I've got 6 for that oxygen, 5 for the nitrogen, 6 for the oxygen. So that's a total of 18. I've used 2, 4, 6 so far, so subtract 6, and I've got a total of 12 left. So where do I put those 12? I always said the outside first, so here we go. 2, 4, 6. Then I'm going to go to the middle. I've got 6 left now. So if I go to the middle, where am I going to spread those 6? Well, I could split them up, or I can just add them to 1. Yeah, I'll start here. 2, 4, 6. All right. Right now, everyone's got an octet except for the nitrogen. So what am I going to do? Well, I could move this one over. That's an option. Or I could move this over. That's an option. Either are okay. So there's actually more than one correct structure for this. The one that I'm going to choose to show to you is this one. And that would be it. Everyone's got an octet. Let's go back to that other one I skipped from the beginning. I skipped the first one for the same reason. The way it's written out, HOCN, indicates when there's no clear center, the order that they connect, the H to the O, the C to the N. So this structure actually ends up looking like this. That's it. Again, we can go over this in class, or you can ask me about it in tutoring. Okay, let's finish up the answers here. So C2H4, not clear about who's the center, but I'll tell you this much. Connect the carbons first because they're going to be in the center somehow. Spread those hydrogens evenly, so, you know, one there, one there, one there, one there. Spread them with symmetry. A lot of you pointed out symmetry in class, and that is very true about these molecules. So it's C2H4, that's 12 electrons. This is 4, that's 16. How much have I used so far? 2, 4, 6, 8, 10. So I have 6 valence electrons left. I can't spread them on the outside, so I got to spread them on the inside. Actually, let me double check. Did I count this right? I've got 6 plus 6, which is 12. 4 there, got 16. I've used up 2, 4, 6, 8, 10. Yeah, that's right, I've got 6 electrons left. Where do I put those suckers? Hang on a second, something seems quite strange. See, this is the important thing. When you look at this, and I'm like, looking at the 6 here, and I'm going, hey, I can't put 2 there, 2 there. What am I going to do? Squeeze another 2 on a carbon? Something's wrong. It's very easy to make mistakes. I just caught myself in a mistake. I said that there's 12 valence electrons for 2 carbons. That's totally wrong. Carbon has 4 valence electrons, so that's a total of 8, plus the 4 hydrogens gives me a total of 12. I've used the 10 so far. I only have 2 electrons left to place, not 6. So where am I going to put them? I'll put them on one carbon. Do I have an octet? Well, I've got an octet on this carbon, not this one. So that's when we have a double bond. C, double bond C, H, 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 H. We're good to go. Okay, I'm going to finish going over these answers with you. This is fluorine, should look like this. Got CH3, NH2. Again, this indicates who's connected to who. The CH3s together and then NH2s together. So CH3, NH2. There we go. Keep those 2 dots in there. Then note HOCl. And that's it for the answers. If you have individual questions about specific ones, let me know in class or during tutoring. Thank you very much.